All right, team, let's get right into it. Think of this as your strategic briefing. I'm your senior powertrain consultant, and for the next few minutes, we're going to lay out the exact engineering roadmap you need to build a competitive electric race car right from day one. Okay, let's do this. First, a hard dose of reality. You see that number? According to data from top competitions, over 40% of new electric teams show up and fail. They either don't pass the brutal technical inspection or their car just dies on the track. Our entire mission today is to make absolutely sure you are not in that 40%.
If you only remember one thing from our talk today, make it this. This is my philosophy after more than 2 decades in this game. A super complex, high-tech car that never actually runs has a performance ceiling of 0. But a simple, tough-as-nails car that finishes every single event, well, that sets a really high floor for your success. Reliability is your #1 goal. It's your North Star.
So, here's our game plan. We'll quickly scope out the competition and lock in our strategy. Then, we'll dig into the big decisions you've got to make on your powertrain and battery. And finally, we'll talk about how to beat the biggest boss, technical inspection, and lay out a clear path to victory. First things first, you gotta understand the battlefield. In Formula Student, the rulebook isn't just a set of guidelines. For your project, it's basically the laws of physics. So get this, the rules cap your maximum power at 80 kilowatts. And honestly, that's what makes this competition so brilliant. It means you can't just win by slapping a giant motor in the car. The whole game is about efficiency, how cleverly you can use every last watt to go fast, and, more importantly, to last the entire 22-kilometer endurance event. And that brings us right back to our core principle. For your first year, every single decision you make needs to be passed through one simple filter. Does this make the car more reliable? You're going to get to the track and see the top teams with their insane four-wheel drive systems, custom motors, crazy aero, and you'll be tempted to copy them. Don't. It's a technical arms race you just can't win in year one. Your goal is much simpler, but it's not easy. Build a car that runs and completes every event. If you can do that, you'll beat more than half the teams there. For a rookie team, finishing is winning. Period. Okay, let's talk nuts and bolts. Your first major decision here is a big one. It's going to set the tone for the complexity, the risk, and the workload for your entire project. Now, four-wheel drive is awesome, no doubt. The performance is incredible. But think about it. That's 4 motors, 4 inverters, a way more complex cooling system, and a control system that's just a nightmare to get right. So for year one, it's a no-brainer. Go with a single-motor, rear-wheel drive setup. It makes everything simpler, letting you focus on making it bulletproof. This brings up the classic make versus buy question. And for your first year, the answer's simple. Buy. Do not try to build your own motor or inverter. Buy proven, off-the-shelf parts. The MRAX motor is a lightweight powerhouse. The DTI inverter is practically made for this competition, and a Drexler diff is the gold standard. You're leveraging their R&D so you can focus on making it all work together. Let's talk about the heart of your car, the high-voltage battery. The rules call it the accumulator. And let me be crystal clear, this is, without a doubt, the single most dangerous, most heavily regulated, and most critical system you are going to build. And the very first choice you'll make on the battery is huge. It's going to dictate the entire design of your pack, both mechanically and thermally. So, which type of battery cell do you pick? Look, the trade-off here is pretty clear. Pouch cells are tempting because they're energy dense, but they're basically soft pillows that are fragile, swell up when you use them, and are a total headache to cool. Cylindrical cells, on the other hand, come in their own little steel cans. They're tough, way easier to cool, and just plain safer. For a first-year team, this isn't really a choice, it's a mandate. Use cylindrical cells. And all those cells have to live inside a container that is basically a fortress. The rules say it has to survive a 40G impact. That's 40 times the force of gravity. Now, you could use fancy lightweight composites, but proving to the judges that they're strong enough is a whole other massive project. The smart play for year one, build it out of steel or aluminum. It's much, much easier to prove it's safe. So, you've built the car. You think the hard part is over, right? Nope. Now you have to prove to the judges that it's safe. Welcome to electrical scrutineering. This is the final boss of the build phase, and trust me, it's where all the rookie mistakes get found. First up, the IMD, or Insulation Monitoring Device. Think of this as the car's watchdog. It's constantly checking for any tiny current leaks from your 600-volt system to the car's frame. If it detects anything, bam, it trips the shutdown circuit and kills the power instantly. It has to be hardwired, no software allowed. Next is the BSPD, or Brake System Plausibility Device. Its job is simple: prevent the car from driving away if something goes wrong. If the driver is hard on the brakes and the accelerator at the same time for more than half a second, the BSPD just says nope and cuts power to the motor. And here is the golden rule, a classic rookie mistake. You cannot, I repeat, cannot use a microcontroller like an Arduino to build your BS and PD. The rules are super clear on this. Why? Because software has bugs, and you can't have a software bug compromise a critical safety system. It has to be built with good old-fashioned analog hardware like op-amps. All these safety devices get wired into one big critical loop, the shutdown circuit. The best way to think of it is like a string of old Christmas lights. You know when one bulb goes out, the whole string dies? It's exactly like that. The circuit runs through all the e-stops, the master switches, and every single high-voltage connector. If any one of those links in the chain breaks, the main power relays pop open and the car is instantly safe. Okay, we've gone through the core strategy and the critical systems. Now let's pull it all together into an actionable plan for you to follow. But before we get to the final keys to success, I have to mention the rain test. Yes, during inspection, they will literally spray your car down with water while the high-voltage system is live. It is the ultimate test of your wiring, your connectors, and your attention to detail. One stray drop of water in the wrong spot can end your entire competition. So it all really boils down to these three things. 1, reliability above all else. A car that finishes is always better than a car that's fast for just one lap. 2, the rulebook is your Bible. Know it inside and out. And 3, test, test, test. The competition is where you go to prove your car works, not to figure out why it doesn't. And here's what your year should look like. Quarter 1 is all about studying the rules and ordering those parts that take forever to arrive. Quarter 2 is deep in design work. Quarter 3 is when you're actually building everything, and this is critical. You have to protect Quarter 4. That is for testing, integration, and driver training. Do not let manufacturing drag into your testing time. It's a recipe for failure. Look, following this roadmap isn't going to be easy, but it will give you a car that is reliable, compliant, and well-tested. It'll get you through scrutineering and onto that track ready to go. The foundation will be set, so the only question left is, are you ready to execute?